Meetup today. Just as a caveat here, we're trying something different. Nick's doing a live stream to YouTube of our WebEx, and that's the first time we've done that for the meetups. Maybe we'll do it in the future for the different venues, but thanks everybody for joining. We're going to talk primarily about GraphQL here today, and I'll set a little bit of context. The use case will involve a number of moving parts, specifically Arista Containerized EOS, and Nautobot's going to be the platform that we use to illustrate and demonstrate this GraphQL. So this is just for reference, the abstract. Again, we're gonna focus on some network devices, so that's why it's for a NetDevOps engineer. So we're going to have some containerized Arista EOS devices, and we're going to set up an environment here where hopefully, if you're interested, a network engineer that wants to learn GraphQL, specifically around the Nautobot implementation, and we have, of course, some Ansible thrown in for good measure, and it'll be very beneficial. So I'm Joel King. I'm going to be leading today the presentation, and we'll provide the links here in a little bit. But we do have a distinguished and special guest today, Damien, and I'd like Damien to introduce himself and tell what his contribution to this whole solution is.
Thanks, Joel. So hi, Damien Garros. I'm Director of Architecture at Network to Code. And so I've been, deeply involved with Nautobot and specifically about GraphQL. So I was one of the main driver behind GraphQL, and I actually did the initial implementations when we released Nautobot. So very happy to see more content on GraphQL. Always excited. I know for us it's been a game changer, I'll say, on how we've been delivering project and automating and integrating, Ansible and Nautobot. So yeah, always happy to see more interest around GraphQL, understand how people use it, and thank you, Joel, for organizing the meetup on that. It's exciting.
And I can tell you, this wasn't staged because I did not know ahead of time that was going to be the case until we connected the meeting invite on LinkedIn, and he told me that, and I said, well, that'll be good because we have an expert, and I'm just a novice at this point, still learning, but I have learned a lot from all of this. So what's in it for me? How we got to this point. Last summer, Tim Hall, who I believe Tim is also on the call here. I saw him dial in. Tim Hall and I were consulting with a large manufacturing company, and they were deploying at scale hundreds of racks of equipment to support a private cloud or an internal data center. And Tim and I were tasked with helping them be able to provide some education around automation of that. And I used that as the opportunity working with Tim. We had, of course, we had Excel spreadsheets, and we had that came from the network architects that were laying out the AS numbers and IP addressing and so on. And Tim and my task was to help teach automation to this particular customer. So that was actually my first exposure to Nautobot, because I looked at the sheer volume of the data that we had, and we wanted to be able to show them a use case where we had a source of truth. And of course, they were using Ansible, and we have experience with Ansible. But when I dug into it, I said, oh, there's a GraphQL interface to Nautobot, and I had worked with GraphQL a few years back. At that time, Forward Networks also had a GraphQL interface, and I had a little experience with it, but very rudimentary. More recently here, we have been doing some work with Arista, and I thought, well, this would be a good opportunity to take essentially what we worked on internally for this particular customer and just give people an idea or a context around how you might use GraphQL. Many network engineers still aren't necessarily familiar with Ansible and structured data and sources of truth. And I just wanted to be able to take what we did internally and condense it down into an environment where we could maybe broaden the understanding of GraphQL and specifically with the Nautobot implementation. So that being said, I have created a learning environment here, a GitLab repository, and I'll just pause on this a little bit if you want to write that down. We will put it in the follow-up of the meeting invite. There's also a QR code there if you want to click that. But in this learning environment, I have a repository out there that provides documentation and some sample playbooks, a number of sample GraphQL queries, so that you would be able to, we certainly will not be able to go into great in-depth here in an hour, but you would be able to take this publicly available repository if you want to fork it or clone it, make a copy of it, and set up and work through these exercises, because it is something that requires some hands-on, and hopefully this use case is available to a lot of people. So the topology that we have for the demo today, I have in AWS EC2, and doesn't have to, could be in a private cloud, could be in a public cloud, any bit of compute that you might have that could support. In my case, it's Ubuntu. The instructions are written for Ubuntu. We have documentation to be able to spin up 2 Arista containerized EOS lab environments. And also, Nautobot has the ability to run in a lab environment in a container as well, which is very good for this type of training and education. In the repository, I have examples for inventory files that would connect via HTTP API or a network CLI from Ansible. So I have examples of both of those. And I have documentation on how to configure the Arista switches so that you enable, initiate those containers or launch those containers, run those containers. And then also we're going to expose some ports. So we would be able to SSH into those, either port 2201 and map that into the container, and 2202 for the first and the second container. And then also we map the ports for the HTTP ports as well. So from our laptop, from the repository, if you have VS Code on your laptop, I have a dev container in the laptop that you would be able to use to execute a Docker desktop under VS Code, remote a dev container, and be able to execute these on your and from your laptop, and then point that to your bit of compute, whether it be DigitalOcean or Amazon or Google, whatever cloud platform, someplace. If you can run an instance of Ubuntu and a couple of containers, you'd be able to go through and do all of these exercises on your own, and it would give you a good start, because I know that Tim and I worked a long time on this. So for this customer use case, of course, they're receiving equipment in and they are deploying equipment. They receive at the loading dock. They need to put power, do initial configurations. Our customer was interested in a zero-touch provisioning. What I have done to facilitate this learning environment is I have a file out here called lab build, which essentially goes through and documents all of the pieces that you would need to set up this environment. It's not automated, but it is documented. And that includes how to download and install the containerized EOS binary, how to create the containers, how to create the networks, do the initial provisioning of that, the things that we need to set up. So essentially what we have in this environment, and I'll show you over here in a second, essentially we have 2 containers that run containerized EOS. And also I have instructions here that I used in order to install the Nautobot lab in that environment and get that all set up. So that's what I'm actually showing you here on my screen. I have Nautobot lab and running, and I have my Arista devices here. I'm going to SSH into them. And you can see that if I do a show run on it, for our use case today, I have 2 Ethernet and a loopback. I have HTTP enabled so that we can do the eAPI, and I have LDP running. So if I do a show LDP neighbors on this device, you can see I have a neighbor, my number 2 router, I'm on the number 1 router. So that's the environment that we have set up here. So that's kind of just to set up the whole thing. Then what we need to do is we need to populate Nautobot with some data so that we can actually get to the configuration portion of it. I've already done that in this case. We have some files in the repository that will build up some pods, some racks, some model numbers, some VLANs, all that sort of stuff. So I've done that ahead of time, but there is a playbook to be able to populate that. And if you look at this Nautobot implementation, you'll see that I have pre-populated this data. Certainly, you can look at the playbooks that's in the repository and you can understand what I did there. I have the IPAM set up where I have my prefixes defined. I have IP addresses defined. I have sites and regions defined and rack groups and so on. So that's all been done. We're not going to do that. We don't have time to do that today. This is for reference. But if you want to try this at home, this would give you a quick jump start on how to get into this environment without going through all of the details of doing that manually. And then also, as a next step, I've also onboarded a device. So there is a playbook in this repository that will go out and has the 2 device definitions that we're working with in our containerized EOS. You'll see that in this example, we have an Ethernet 1 and 2 in the loopbacks. So I've provided some of the configuration data in YAML format for this particular device just to populate it, just to get it up to the point where you can go in and start experimenting with GraphQL and not have to spend hours upon hours defining all of the front end work to be able to populate Nautobot. So here's our CEOS1 router. You see that I have Ethernet 1 and 2 defined. I have IP addresses on it, and I have MTU values and so on. So that's setting up that environment. And just for reference, it's what it looks like in Nautobot. So we're kind of building the background here to be able to get to what we're most interested in here today is understanding the GraphQL piece of it. So I'll just pause there for 1 second. In terms of context, I mean, this is a hands-on lab environment that you would be able to try at home. Any questions before we kind of dive into GraphQL? I take that as we're all good.
Hey, Joel, no question, but there was a comment in the chat about whether you can make your screen a little bit bigger, the window that you're sharing from.
This
the
one
slideshow.
here?
I think so. Yeah, there's a question in the chat about that.
Yeah, that is probably about as big as I'm going to be able to make it and be able to jump back and forth here. But we will have the slides available on the community page afterwards as well. So let's just do a little bit of history here in terms of GraphQL. GraphQL was developed in 2012 primarily to solve a problem with Facebook's rewrite of their mobile apps. It's best described as a query language for APIs, and the problem that they were trying to solve is due to the fact that for mobile apps and mobile devices, you want to be as efficient as possible in terms of returning data. Obviously, bandwidth in those environments is precious, and compute power on a mobile device, while robust in today's standards, still is somewhat limited. The idea behind it is that it would return JSON data back to the mobile device, and essentially it would, unlike APIs, would allow the client to be able to ask for or describe the data that it wants to receive, not what the full population of data that that server may be able to serve up in a traditional API. So some of the comparisons, and this isn't like an either or. So if you think about it, the pretext that I had here about setting up Nautobot and populating it, that was all done with APIs. That was all done with Ansible playbooks that used the Nautobot Ansible communities to be able to, and plugins and modules to be able to, or I'm sorry, the collection modules to be able to load all that data. So the GraphQL piece is going to tie into primarily from the retrieval of information, although it is possible in some implementations to use mutations to be able to modify the state in the server. Our use case today is going to talk all about supporting queries. And of course, we're using the traditional API, REST APIs, post, patch, get, delete, all of those verbs. We're using those to be able to push data into Nautobot, populate Nautobot. Other difference between GraphQL and APIs is the fact that you have a single URL as an endpoint. So we're always going to be sending a query into that endpoint. The server is going to interpret that and also substitute what variables that we may send into it. Whereas with a traditional REST API, each resource has a different or separate URL. The other advantage is the fact that GraphQL returns the data that you ask for. So we'll see some examples of queries, and that has a side benefit of avoiding having to do versioning. So if you've worked with APIs, maybe it's Meraki API or other vendors, they might start out with a version 0. They'll add additional features. They'll go to version 1, version 2, version 3, and so on. That's less of an issue with GraphQL because you are asking for the data that you want to retrieve. So you have a stake or a voice in the information that's coming back. The query fields that you ask for are the same as the results. You get back what you expect. Whereas with Postman, whereas with a REST API, often we'll use Postman or curl or the documentation in Swagger or OpenAPI to be able to understand what we're going to retrieve or what we're going to get back. Well, the reverse is true with GraphQL. We're going to specify the fields that we're going to ask for, and then we're going to get that back. So it's a little bit more deterministic. And then you can supply arguments to these queries. And one of the things that you can do with the argument is implement a data transformation. So if you have a unit of measure, if you have height as one of the fields, and you want it in feet versus metric, you can do those transformations on the server side. We're typically with a REST API, we're going to do transformations on the client side. So we're going to manipulate the data afterwards there. And then, as I said, it's not an either or, it's a combination. So what we're going to examine today in this playbook that actually configures this Arista switch, we've loaded Nautobot, we've populated Nautobot with this data from YAML files through the Ansible collection APIs. We're going to use GraphQL to query Nautobot. We're going to use the Nautobot query_GraphQL module, and that's how we're going to retrieve the data from Nautobot to be able to configure the Arista Containerized EOS devices. And it doesn't have to be Arista. It could be NXOS. It could be any switch or router. We're just using that as a specific use case. And I dropped this URL on the screen here as well. I use this a lot. This is the GraphQL Learning Introduction page. It's a good resource. There's some other resources out there as well. So one of the things that is very beneficial with GraphQL is this concept of interactive or GraphiQL. And in the Nautobot implementation, if you look at the lower right-hand side of the screen on any of the screens, and I'll bring it up here in a second, you'll see a little selectable box here for GraphQL. And that endpoint is going to be GraphQL. And when you do that, you're going to see this interactive within browser tool for writing, validating, testing your queries. And that's what we see here. If we click on GraphQL, and in this case, I already have a query loaded in here, but this is how you would understand how to develop your queries. In our use case, those queries then are going to be input to an Ansible module. But in order to develop the query, we're going to use this GraphiQL to be able to do that. So you see in this example, I have a query in the dialog box. I also have some variables for that query, and we'll talk about that in just a second. But I can essentially execute that query simply by pressing the query, and I get an answer set back. So you'll notice in this particular query, I've provided some variables, and one of those variables is an MTU. So I said an MTU of 9,000, and we'll talk about this in a little bit more detail. But essentially what I'm doing in this query is I'm asking for any MTUs that are less than 9,000. And you see when I clicked the box, I had some devices that were returned that didn't meet that criteria, so I have an empty list of interfaces. But in this particular device, you can see that I have an interface. Remember, all of these devices have Ethernet 1, Ethernet 2, and loopback defined. You'll see in this case, I was able to query, and this MTU of 1524 is less than the MTU of 9,000. So this IQL interface is very useful for developing these particular queries so that you understand when you go to the automation approach and port that into Ansible, you have pre-tested or understand what data that you're going to get back. So in the so that's very valuable, very useful. Let's kind of just drill into, and I'll bring this up in the repository. But this particular query that we're going to use to configure the Arista Containerized EOS devices, this query is what the interactive query language is what I use to develop the query, and then use that to input that into this Ansible playbook. So in this example, I have an Ansible playbook here to configure device. And we'll just scroll down here a bit. And you will notice that in the development standpoint, I use the IQL be able to formulate what fields I'm interested in, save those fields out into a file. So in this case, this query is saved into a file, and I have provided those graph variables that I mentioned as a dictionary to the graph variable argument to the query GraphQL module. And if we take a look at that, an important point here is we take a look at that particular file, query interfaces, you'll see that I simply cut and paste it out of the IQL. And as a comment, I put my variables down here just for illustration purposes. But this is an input to that module to be able to return that data back to the playbook. So if we take a look at this playbook snippet, you'll notice that I'm issuing that GraphQL query, and I'm registering that variable. And within that, then I'm able to reference this data that is returned from that variable in my playbook. Again, from a development standpoint, very important to be able to understand exactly what you're getting. You don't need to use Swagger. You don't need to use Open or Postman or anything of that nature. Your development environment is here. And one other thing that's very important is if you click on this box, you have your schema definition here. So you can see what variables are available to you in each one of these. So let's look at devices here. And we can see for devices, we have these different different arguments or different variables that are available to us. We do have the ability to be able to make some changes to it as well. So in the GraphQL, if we go out and do a control space, we can see that we have populated here the different values that we can use. You notice that this has subfields. So you notice that in GraphQL that we have some underlines there. And within those subfields, then let's just say color and issue it again. So now you see that I was able to interactively here add some additional fields in this dialog box, execute the query, and now for my return data set, I have included status and color. So it's a very easy way to understand what data is available to you, and then to be able to see what data that is returned, and then incorporate that into your Ansible playbook to be able to populate that into, in this case, our containerized EOS. So I showed you some examples of arguments, and I said that arguments can be provided in these queries. In this example, these arguments are static or hard-coded. So every field and nested object has its own set of arguments. So in this example, we have this basic query that shows devices and interfaces, and I'm asking for the device that's named ceos1.example.net and an interface named Ethernet 1. So recall that I have a Ethernet 1, Ethernet 2, and loop back on the devices, but in this case, I'm only interested in, for whatever use case, my Ethernet 1 interface. So note that I do not have as my result, I don't have a loopback 0 or Ethernet 2 because I've bounded that query by these particular arguments. So that's a very powerful feature in terms of only asking for specifically the information that you need. What's more important though is combining those arguments with variables to be able to provide some dynamic value out of the query. So by transforming those static or hard-coded arguments, we can declare variables in the GraphQL query, and then we can substitute that variable name as opposed to the literal string in the previous example, and then we can pass those variable names in case of the Ansible playbook through that argument to the Ansible playbook, or in the interactive GraphQL, there is a query variable area here where this JSON data can be input or modified. Let me just change that. We can certainly change that and issue it again. So the fact that you have the ability to pass a JSON data structure variables and have those substituted in the query is very powerful, in that you don't have to make changes to the query, but you can provide variables in that query and then pass those variables in at runtime. And we'll see how we do that here in just a second. We can also do some things with limiting the results. So here's another example where, in this case, there are, in the schema itself, there are conditionals essentially. If we want to only look at MTUs that are less than and equal or less than a certain value that's in that variable, well, we also have that as well. So if you'll notice in this example, we've specified that I want to look at MTUs that are less than a certain value in that argument, and I want to look at a specific host. So in this case, I said I'm going to exclude anything that includes foo.org, and I want to look for interfaces that have MTUs that are less than, in this case, 65,536. So that gives us the ability here. So we have example.org. You notice if we change this to foo.org and we change this to 65,536 and issue the query again, now our answer set is much more verbose because we have we've increased the MTU, and now we're finding MTUs that are both 1524 or MTUs that are 9214. So where this would come into handy, where this would be handy is, for example, let's say that you had a network operator that had populated some fields in Nautobot and they used the wrong value for MTU. So they used 1524 instead of 9214. So your data itself is tainted or incorrect. Well, if you want to fix that and understand which devices are misconfigured in your source of truth, you could have a playbook that looked for those devices or those interfaces that were misconfigured, fix them or address that in your source of truth, and then go back and apply those changes to those particular devices in your network to be able to clean that up. So it gives you the ability to be able to provide variables and to be very specific, again, about the data that you're going to retrieve. So that's a very useful feature as well. And then you can have more than one query in a request. So one of the examples that I have, and I have this in the repository, here's an example where I look for devices that we saw earlier with the name of CEOS1 example.net. We looked at Ethernet 1, but in the blue down here, I also have a second query for device roles. So if we look at our Nautobot configuration, you can see that we have a tab here for devices, and we also have for device roles. So within one query, I can bring back leaf spine, super, top of rack, unassigned, and so on. But I can combine, that can be combined all in one query. So you can bring back, be very specific about different types of data that you want to bring back to be able to populate, in our case, that Ansible playbook. So that's another nice feature as well. And then here's a tip, and Damien brought this up to me. He said one of the common mistakes I think that people make is returning, and correct me if I'm wrong here, but returning too much data. So in this case, the way the sample playbook that I've set up here for configuring our devices is I pass the inventory host name, in this case for our playbook, and issue a GraphQL query for each of those inventory host names, as opposed to doing a query for all of the devices in the inventory. So, Damien, do you want to comment on that a little bit, or is there anything that you want to add to that?
No, I think you covered it. Yeah, really, keep the inventory as small and fast as possible, and then query more information per device as needed within the playbook. So now that we have the GraphQL module, it's very easy to do that. I forgot to mention, actually, we have Josh on the call as well. And Josh actually is the one who is maintainer of the Ansible module, and he wrote the GraphQL filter that you're using as well. So a lot of people in the call.
Very good. Thank you. Thanks. So just a quick demo here. So I have we looked at it earlier here. We have our one of the two Arista Containerized EOS devices. I'm going to do a show run. You'll notice that we have the interfaces, but we don't have any IP addresses on them. So what I'm going to do here is just to point you where this is at, but essentially in our documentation, I have documented all of these steps, so you can. I know some of you people said the screen's a little bit short, but we're gonna configure a device, and I have documentation here for configuring this device, and we're going to initiate that. So essentially, we're executing the playbook. The playbook has the GraphQL query defined as a file. And we're passing into it that tip that we saw earlier, where we're passing into it the inventory host name. And you'll see that we're going through and hopefully putting some IP addresses on these particular devices. And we should start seeing IP addresses. And in this case, we can do now we have some addressing here, 192.0.2.1. So now we have IP connectivity in addition to our LLDP connectivity. So that playbook that I just executed is this configured device playbook. And our query string there for that is going to be, and I have it in the notes here, example of that. We queried for devices, we bounded it through this variable device name. Device name is the inventory host name of the Ansible playbook. We brought back these fields, and of course, you can add, decrease, whatever you need for your particular use case or playbook. And this is just an example here. In this case, the variable that we passed into in this example was the second router. We have a description, we have IP addresses, we have MTUs, and all the values, but that is a representation from a verbose output of the playbook, what you might see. And of course, you can see the interface here as well. So with that, it's a quick demo. There's also an inventory plugin, and I won't demo that, but there is a playbook here in this sample repository that references the inventory plugin. An example of that here. So you can take a look at that inventory plugin playbook just as a demo. Which is this playbook. So there's an example here of using GraphQL as an inventory source, and I have a configuration in there as well for that. And then another important feature, and this is really extending it a little bit. One of the features of Nautobot is the ability to do Git as a data source, and we can combine that with GraphQL, and I think that also is a very powerful feature. So in this example, we have Nautobot has the ability to do what's called a config context. And I have an example of config context set it up in this GitLab repository, both examples in JSON and XML. So within Nautobot, I can retrieve that data, that Git as a data source, and populate the config context in Nautobot. And I'll show you where that is. Under config context, I have a device defined, and I have a number of tags, configurations based on a tag defined as well. What we can do then, once we use that config context and Git as a data source and populate Nautobot with that data from, in this case, our Git repository, we can reference that config context because that is a field under devices, and we'll end up populating that field under devices. So that's very powerful too, is the fact that these things all tie together. So using Git as a data source in Nautobot, you would reference the remote URL, any tokens or credentials that you need, and then it will go out and initiate that retrieval of that information from our Git repository. And then once that information is retrieved, in this case, the use case that I had is I applied a tag to both of the top of rack switches in a particular rack. So in Tim and the customer that Tim Hall and I worked with this summer, they had external BGP. They had two top of rack switches. They had the same AS number on those switches. And as an example, I created a config context and used the tag value as the operative asset or argument, if you will. And then I'm able to, when we do this query, I'm able to populate that config context for both of those top of rack switches because I've tagged those switches with the rack number that they're in. So we're making use of that data so that we can either tag values or use sites or regions to be able to have specific data for specific use cases in it and still be able to populate that in GraphQL and not necessarily use the API to be able to retrieve it. So that's what this file looks like. So in this case, I've said I'm using my metadata is I'm using a tag. I've defined the AS number, and I've also defined, you can define some ACLs or any free-form data that you would like, structured data, but any data that you would like to associate with that particular tag. And then the results will include that. So if I go back to the query that we have been working with here, looking at in our interactive GraphQL, I've commented out the config context here. But if I take that comment away for config context and issue the query again, you'll notice now that I have returned as input this config context and the AS number. And I apologize, I have some dogs here that are getting upset. But we have this config context that's able to be able to come in there as well. So with that, and that's the dog is barking right now, so he's on cue, I think. So with that, I mean, in today's talk, we had set up a learning environment. We have Arista Containerized EOS. We have Ansible examples in a repository. We have a dev container in VS Code, and we have Nautobot running in a lab environment. We took a look at the overview of GraphQL. We looked at the interactive portion of GraphQL that's built into Nautobot. We examined the use of arguments and variables, which is very powerful from a standpoint of doing queries with GraphQL to be able to retrieve just the data that we're interested in. We see that there is an Ansible inventory plugin for Nautobot. And then also we looked at config context using Git as a data source in Nautobot, and then how we could reference those config contexts in a GraphQL query. So that's what our today's example was. And Nick, I'll turn it over to you if you want to talk about this a little bit. Nick's been kind enough to do a lot of work here to put our past sessions and content on the platform. This is free. Meetup has no way to store recordings and store content. And Nick, why don't you just highlight and talk about that a little bit and what you're doing with the streaming as well.
Thanks, Joel. So yeah, like Joel said, Meetup has no way for long-term content storage as it relates to any of the sessions that we've done. So I just dropped the link in the chat for anybody that's interested, but you can use wwt.link/meetup, which will direct you to this community on wwt.com. You do not have to have an account if you don't have one. Everything is open, but we've got kind of information as it relates to our.
Why do I care? I don't know.
We've got information as it relates to our past sessions, upcoming sessions. Call for presenters is also out there. So if there's like all meetups, if there's anything that you're interested in or anything that you want to share, with the group, please go out there and fill out the form, and we'll be in touch to get you on the schedule. But outside of that, again, all of the past sessions, the recordings are there. And really that's going to be kind of just our long-term storage place for all of these past meetups, including, all of the relevant links and copies of the presentations and things like that as well.
So you'll notice that Nick just reorganized this. There's tabs. It used to be all on one page. There's tabs at the top of the link there for past sessions. It's in the green dotted box, past session recordings, and then some other information and another content that we have at WWT. got a couple of resources here. So some of the things that I use to research this, about GraphQL specifically, the link to the repository, link to the recordings that we just mentioned, GraphQL user's guide for Nautobot, some details in a blog post there on config context, Nautobot solutions guide, and we'll post these slides in the link that we just saw there earlier. And with that, we'll just open it up if anybody, any questions, comments, anything, folks from Network to Code there, if there's anything that you wanted to emphasize that I skimmed over, please feel free to chime in.
Yeah, I think that was a great demo. One thing maybe we forgot, and it's actually features probably don't use enough. There's a way to store a GraphQL query in Nautobot and just execute them, like, so that you actually don't have to store the query. You can just call a URL and pass your. Also, you already have it here. Oh, perfect.
Yeah, I have one. I have one in here. I did that. I thought that you can go ahead and talk to it, but I did store one in here to illustrate that point. And why don't you explain that?
So yeah, the idea is that you can store your query in a server so that the query can evolve and anyone can just query it. And if it has specific variables, then you just have to provide the variables. So it's another way to share your query between projects. And so yeah, I think it's a very useful features where often we just forget about it, but it's there and it's available, because sometimes query can get complicated, and the goal is to really have like a query instead of having a single query that will be reused for every use case, or goal is really to have different query for each use case so that you really optimize what you're getting back. So that's a great feature for that.
And correct me if I'm wrong, but you can initiate those queries from the REST API to be able to invoke them, correct?
Yeah, absolutely. And I think from the GraphiQL, you can even like store and restore from the saved query. If you actually are on the GraphiQL interface, you can do your own query and you can say save by clicking here, and you can say save the current query as a saved query, or you can load one of the saved query into GraphiQL.
Yeah, this is the one that we were just looking at here, is a saved query, and then we could save this query. What I've done, because this is a lab environment and it's in a container, I've stored them off in the repository because I could potentially destroy this environment, being that it's a lab environment. So it's an ephemeral environment. So that's why in the example here, I stored them in underneath this playbook files for my queries, just cut and paste them in or save them out to be able to do the different queries, because this is more permanent than when you're running Nautobot in the lab environment, because it would be a dev environment that might get torn down and rebuilt.
Yeah, that makes a lot of sense. There's actually a features request to be able to store saved GraphQL query as part of a Git repository. So you have this ability today, for example, config context, you can have them in Git and integrate that natively into Nautobot. There's a feature request to have saved GraphQL query as part of that. So once we have that, there will be another very useful way to store them and synchronize them with Nautobot.
Okay, thanks for that. Any other questions or comments? Well, if not, I appreciate everybody's attention today. Realize this was a lot of information in a short period of time. We could probably spend a couple hours on this, but certainly you have the link to the GitLab repository. hopefully the documentation there to be able to build your own environment. You can experiment with it. And certainly I'm trying to make it as easy as possible for people to bring up an environment and experiment with it, because that's really how you learn, is the hands-on approach to it. So,
Joel, this is a good comprehensive cover, and I'll also allude that GraphQL is definitely much quicker. We've seen where using GraphQL, the queries get the data you want is at times minutes faster than a REST API call on the same box. So yeah, GraphQL definitely from a getting of resources is the efficient route to go.
okay, very good. Thanks for sharing that. Okay, Nick, I guess we'll hand it back to you.
Yeah, no, again, Joel, thanks for presenting. Damien, thanks for hopping on and providing color as well. And then nice work to Josh on the module that Joel was using here to query Nautobot as well. It's a really, really interesting thing, and I think this is a good foundation for anybody that's new to this. So with that, we'll give everybody about 5 minutes back of their day, and thank you everybody for attending. And like always, we'll have another topic here in the coming weeks, and stay tuned for what that is. We'll get the link posted as soon as we get the abstract done. So thank you, and have a great day.
Thanks, everybody.